close the caption, you can hear yourself and what is the sentence you are talking.
Okay, sir.
Many of the people gathered here would be around your lunch time, but we are starting it. Hopefully, we will leave you in the afternoon very early so that only we preponed this session to 12 p.m. Much of the people who are about to celebrate that or late night, those who have celebrated Christmas, they might need a rest in the afternoon or at least after the meals. So I hope our session speaker is also completed with all his formalities, or at least he has adjusted towards this timings. So I must be to thank him for his commitment to this time, even though this is a holiday. So it's about 12, sir. Now we should rightly initiate the session with the introduction to our guest here. First, I will give one opportunity what is given by Dr. L. Martin here. I met him at Manakula Vinayagar College at his premises while they were conducting a faculty development program on Industry 5.0 and its impact on smart manufacturing. So he's a very enthusiastic and very agile person. And his role in making the College of Manakula Vinayagar to be a very prominent and popular among the people to bring more admission and more fame is very, very important. And to give a proper introduction, I invite now Dr. Anish to speak about the guest here. Anish, sir.
Yes, sir. Good afternoon to all the professors and participants here present in the session here. I'm pleased to welcome you all to the session. I'm also very pleased to welcome our resource person, Dr. L. Martin, Associate Professor from Sri Manakula Vinayagar Engineering College, Puducherry. He is serving as an Associate Professor at Sri Manakula Engineering College from the year of 2011. He holds a PhD from Pondicherry Engineering College MTech in CAD and BTech in Mechanical Engineering from Bharatiyar College of Engineering and Technology, affiliated with Pondicherry University. Dr. Martin Sir's professional journey uh, started from Manipur Engineering College, and he has been from 2011 and now up to now as associate professor. He is also actively contributed beyond teaching as ACT Idea Lab Tech Guru, Institution Innovation Council convener, placement and training coordinator, faculty coordinator for examinations, NP and NAC coordinator. He is also elected as a committee member, Mechanical Division for the Institution of Engineers India, Puducherry Center for the period of November 2023 to October 2025. His dedication to innovation research is evident through his involvement in various projects, patents, and publications in reputed journals. He is also proficient in various design and analysis softwares such as AutoCAD, CATIA, ANSYS, and MATLAB. Sar is also skilled in programming languages including Python and Java. His expertise spans to multiple domains from CNC machine building to IoT, AI, and machine learning. Dr. Martin Sir is a valuable asset to the field of mechanical engineering and academia due to his esteemed commitment to education and research coupled with his practical skills and innovative mindset. Welcome you, sir.
Thank you, Anish sir. Thank you for the introduction.
Yes, sir. Sir, I stop sharing my screen. You can share your own PPT slides.
Okay, I am sharing my screen. Sir, is my screen visible, sir?
Screen visible, sir. There is a second screen on your left, sir. Can it be minimized?
Is it okay, sir?
Now okay, sir. Now audio is okay, and your screen is also completely visible, sir. Please proceed, sir.
Yes. Good morning to all the participants. First of all, I should thank to invite me for the FDP. So the FDP is Emerging Material and Advanced Technology for Sustainability. So thanks to the management, chief patterns, convener, and co-conveners and coordinators for this FDP. Special thanks to Dr. S. Muthukumar sir for inviting me. So even though it is in holiday, and I also welcome all the participants who is attending in online. First of all, today is Christmas, so I wish happy Christmas to all the participants. Okay. So myself, Dr. Martin, already they introduced. Actually, my work is actually in IoT. We have Idea Labs. In the Idea Lab, we are collaborating this thing. Okay. So this is my almost 500 plus FDP as a resource person through Idea Lab or IAC. So in online, after Corona, long time back, so now I am presenting in online. So I know it is very difficult to get the attention from the participant. So today's topic is IoT plus machine learning in revolutionizing material science, smart sensors and AI transforming material. So I should want, I think all of them mechanical engineer. Am I right, sir? Hello, sir.
Yes, sir. Yes, sir.
Here, so everyone know about the material testing. Anyone can please chat in this message as what types of material testing we have in your college, or can you able to tell me a chat? Or you can unmute and you can speak. What type of material testing is available? Like, okay. I will tell you what is the IoT testing and the normal testing. So in a hospital, if per patient per day, if you are checking, means that is the normal testing method. But as advanced in IoT, the testing will be like ECG. Continuously, we need to monitor the whole material property through online. So here we have 6 chapters. So the first chapter is the challenge of the material testing in mechanical engineering. So traditional material testing, so it is manual method, it is basic equipments. It is isolated machine. Then in that manual method, so it is like checking a patient only once a day. IoT is like a continuous ECG monitoring. You see the problems before failure. But the existing method, if you go same material testing in 2 different labs, we can have the 2 different output. The breaking load at first lab is 420 megapascal and second lab is almost 440 megapascal. So which one is correct? It is very difficult for the traditional method because here it is human error is also available. So in IoT, some sensors we are using to get the data in real time. So the waiting game. In traditional method, testing takes weeks or months for the result. But like in IoT, like machine learning, we will come to later. In IoT, it is like the flow is we need to take the put the sensor all over the material. Every pin and point we can check and we can monitor in online. So because human error is that the same machine, same sample, if you are testing 2 times, same result won't come. Because of the human error, those who are applying, only we can able to monitor the peak load. Breaking load only we can able to get the output. But in IoT, we can check the monitor the material from 0.1 to 100% failure, we can able to calculate. Then the cost of failure when material fail. Think, so if your material is failed means, think about how bridges break or any building is fall down. So the material plays the main important role in today's ecosystem. So we need to, an early stage traditional method, if it is failure, it is very difficult. But now we can able to monitor the railway track point by point, and we can able to monitor the bridges at point by point. We can put the sensor and get the output data and put it in a cloud system, and we can able to monitor. So from the basic problem statement, then chapter 2 is goes to for the IoT revolution. So how IoT is revolved in the material testing and material processing, material characterization and all. So today's as per the schedule, I am going to limit only for the testing and the material properties only. You know, if you want, you can further we can discuss about the characterization also. So sensors everywhere. Initially, for take a railway track or a train, so we are taking sample for 1 kilometer one time. We are every time if a train is traveled, before that we need to check the railway tracks. So manually they go and check. As an experienced person can able to check the material failure even from the sound itself. Likewise in IoT, we can able to check from the sound or vibration. So every point we need to put dot sensors. All the sensors are connected together. From the connected together, real-time data they are taken from the sensor, and we can able to monitor in a IoT system cloud. Then from the cloud, so we need to take the decisions using the machine learning. That is the today's problem. So IoT is nothing but, so everything is connected to the internet. So every material at every point we are connecting the data to the material. What strength of the material per second we can able to calculate in today's IoT. So taking the putting the sensor, from the sensor all the data have been real-timely transferred to the data flow, instant connectivity through internet. Everything is connected and should be displayed in the database. So all different types of sensor like temperature sensor, vibration sensor, sound sensor, or any other data we require, we can put it in the material which is in applied field. Initially, what they will do, they take the sample and put in a lab, then testing, then they're checking and they are posting the what is the failure material, and they are predicting how much life the material is having. From that factor of safety, we can apply in a real-time field. But in today's technology, so we need to check the every part in a instant time we need to take the data and we need to check, so that we can able to predict whether the track is failure or not, the bridge is going to failure or not. We can able to calculate the product life cycle. So end life. So normally if you are purchasing any product, so they have some expiry date or they have some manual. So that expiry date depends upon the calculated from the lab. But in real time, it will not work as per our calculation, because in field, air resistance is there, climate change is there, or even some real-time problem is there, human error is there. So it is very difficult to make the system continuously working. So that we need the data in real time. That's why the IoT is revolved and using the sensor and take the data, and we are monitoring through some product life cycle management. So 24/7 we need to monitoring physical meets data. Even in tensile machine, in traditional method only the peak load only we can able to see, but in today's IoT we can able to see the graphs from 0.0 to maximum ultimate stress or breaking load. We can able to fully draw the graph using the latest IoT machine. So it is very useful for the material properties. Then we have microscopic intelligence, nanoscale reduction. In IoT, the sensor will sense at a nanoscale. So material will be, we can able to track using the sensor through the nanoscale reduction. Then the third part is machine learning breakthrough. What is the machine learning breakthrough? It's nothing but it will, the program itself, they take the data. From the data itself, the model is trained by the models. So we have several different models, CNR or FNN models are available. So taking the data and we need to process it and we need to have the previous experience. So think about a fresh person who is entering into the lab and they are designing some samples as per ASTM and put in the machine. They are checking the data. For example, if the person, those who are working in the lab, those who are having the experience, they don't have follow all these things. They directly go and put the material. They can able to calculate the load things. Even I already explained that if you are seeing the material itself, the material property they can able to check from the learning. So we need to feed the data into the computer through IoT in cloud. So every second, every pinpoint data, collect all the data and transfer the data into the cloud. From that cloud data, take an example, if 100 parts are there at different point, which part is going to be failure first? We need to calculate and study why the part is failure. So from that data, so we need to train the model from the machine learning. If the data is less than countable, then it is a machine learning. If it is uncountable, then we need to go for the deep learning. So this neural network method calculate everything. Take an example. For example, if you are having this smartwatch, it will calculate the heartbeat. From the heartbeat, we can able to put the threshold value. Normally, a normal human heartbeat, it counts from 70 to 80. It depends upon different condition. It is at sea level as per our age. So as a 20 years age, up to 70 is good. If the age is 70 plus, then 60 is a abnormal. Those person who is in the hill station who can able to climb and take honey, heartbeat is normally 90. So every different person, the heartbeat threshold value is different. So what the machine will do, it will read the data from the smartwatch of the heartbeat and take that point as the initial reference. So at the age of 35, my heartbeat is 70. If I am running hard, my heartbeat will increase. Then if I am working hard, or if I am busy or some doing work, heartbeat will change. So this change will be automatically every second, it will record it and it fixes the threshold value. So per hour average, per second, if I am taking the heartbeat, per hour my heartbeat average is 70. Tomorrow the heartbeat range will be changed to 80 or 90 or 60. From if it is suddenly increased means then only it only calculate the heartbeat. So likewise in machine learning breakthrough, so every single point data they are collecting and they are normalizing, average it, and from that threshold value we need to calculate the remaining value. So actually in challenges, what is the challenges was, one tensile test is nothing but take an hour, time consuming. If you want to go to the lab, we need to manually taking the tensile test. It takes from the tensile machine, it takes 1 hour. So only limited data, only peak values only we can able to capture in the traditional method. Then third point was human error. different operators, different result. Same machine, if two operators are doing, for different operators, it will give different result. Lab data versus real world data versus mismatch. So from that only we are changing this. Then again I am telling two lab other same material. One report says 420 megapascal, another report says 445 megapascal. So IoT reduces this ambiguity. So industrial example, failure of the components due to lab tested versus real environmental match. In industry, whatever we are testing in the lab, it will be okay, but in the real-time environment, it is mismatch. Then using that, we can able to pattern recognition. AI sees the invisibly. If you are having the front end, what is inside the core also we can able to recognize using the model from the machine learning. So we have the data only at the off only. From the 50% of the data itself, we can able to predict the remaining 50% of the material. If I want to calculate 100%, 100 meter, it is easy for me to calculate only 50%. From the 50% of data itself, we can able to calculate the remaining 50% using the pattern recognition. So IoT infrastructures, it is IoT flow is first one is sensor, it sends, then DAQ, it is collect, then edge, it will think fast, then cloud, it is think deep. So real time, it is sensor, sense organs, edge computer, brain reflex, cloud, memory plus intelligence. So take an example, practical example, strain gauge plus load cell on a UTM machine, wireless data streaming to the dashboard. Then predictive power. ML algorithm can predict material failure 80%, 87% more accurately than traditional method. So you can able to probability also increasing. So weighted importance, project lifespan also it is 24 months. So time span also it is good. Failure also you can able to calculate. Then which property is more critical for bridges? Nothing but so traditional formula versus ML learning. Regression versus strength prediction, classification, failure or no failure. So from the data, we can able to classify whether the material is failure or non-failure. So learning from the SG. The AI will learn from the SG. From the starting stage, if you are putting this sensor, data is transferred, real-time data is transferred from one point to another point. Every day by day, automatically the machine learning, it will be learning by itself. So there are lots of methods are there. It is CNN for the microstructure images, RNN for the fatigue and the creep data, future extraction importance also available. Some case studies will give you some sample, tensile testing also. Throughout it is increasing, accuracy is more important, and it also automation. And predictive maintenance, unexpected failures are reduced, cost is saving. The latest application like aerospace, automotive, biomedical are using the IoT and machine learning. Then the fourth chapter. So I am recalling the chapter 1 is the material failure, and chapter 2 is it is IoT, then chapter 3 is machine learning, then chapter 4 is a real world application. So what is the real world application? So in aerospace innovation, the flight safety is real time. So it is not a static one, it is a motion. So we need to check the whole flight acoustic should be monitored point by point, and the data should be displayed to the pilot. So the pilot, if even a crow or any air resistant, it is affected to the flight acoustic, instantly the pilot can able to detect. So throughout all the acoustic have been connected to a single point, and it should be displayed in the pilot. If any failure is going to be happen also, automatically the pilot can able to take the decision, and they can able to land the flight. It will save the distraction of the flight. Nowadays the flight firing damages, material damages have been reduced due to this IoT and machine learning model. Then bridge safety. So every bridge is all the points have been connected to the internet. So an engineer can able to single point can able to calculate what is the thermal stress, what is the vibration, what is the load capacity, everything able to calculate it in single point. They can able to prevent the problem which is available in the bridges. Then so automotive breakthrough. So in car itself, even if you go into the car, you can able to calculate what is the air pressure in the your tire. So what is the fuel available in the tank? What is the water level, water indicator, background, everything we can able to indicate. In that machine learning method, it's calculate the body material of the automotive material. We can able to track which part is failure. We can able to calculate through this IoT method. And in nuclear power plant monitoring, it is very difficult to monitor a nuclear power plant. In the nuclear power plant, ultimate safety standards are required. So every single point they need to, the material data should be transferred to the cloud. From the cloud, we need to take the decision. Then the chapter 5, it is results. So after taking everything, we need to the results. The result was in real-time method, traditional method, it takes month. In IoT method, it takes minutes. From month to minutes, the revolution has been changed. In traditional method, it takes more than month, but in IoT ML testing method, within a minute, within a second, we can able to get the results. Then accuracy is 95% improved through the traditional method. So our IoT and machine learning method will be 95% improved in the existing method. Then cost saving. Then think about the industry, all the machines, everything, every material should be connected in a cloud. So if anything tick is means it is good. If it is in a danger position, directly we can able to continue. It saves $2.3 billion saved annually throughout the predictive maintenance. So this IoT will give us the data, what we need to predictively, we need to do the machines, parts, workflow, everything. Then it is a zero failure. In IoT, there is the failure is zero. We can able to calculate the material flow. We can able to calculate the system health. We can able to calculate the environmental monitoring. We can able to calculate the equipment status, protocol, compliance, data, integrity, complete. If it is everything is good, goes good, then there is a zero failures in a perfect safety record. And the sixth chapter was the future. So what is the future of this IoT ML material testing? So it is a self-healing. But now what they are doing means, if you're taking the data, if the material is going to be failure, the human only go and replace the material or stopping some predictive maintenance other. But in future, due to the data we are having through machine learning and deep learning, the material automatically it will heal. If the material is going to failure or crack, so automatically we can able to add some solution to the material to self-healing. So that the material will never failure in a real-time environmental. So it should be 100% work through the sustainable. Our topic is a sustainability. So our future is nothing but in material there is no failure. It will sustain fully for the life. So if it is zero failure, automatically 100% healing happens means then sustainability to future is very good through this IoT and ML method. Then global material intelligence. So worldwide the data is sharing. If I am taking the data in Pondicherry or in Chennai, the same data, same model, same method will be shared to the globe. So all are having from the reference data, automatically they can able to implement. But even though we are sharing the data, at initial stage, we need to predict, check maintenance of the initial value. Then only we can able to apply in a real time. Then what is tomorrow's world? Tomorrow's world is nothing but intelligence materials everywhere. So all the material building, machines, road, everything is connected. Even in a road, if any road is cracked, automatically the message sent to the certain department, automatically the preventive maintenance have been taken. So as per my presentation, this is my lecture. The next 15 to 20 minutes you can ask. So myself, I am having running an idea lab in our college. So I am also the IEC convener. So I have almost conducted 400 plus offline FDPs in idea lab. Through IEC, almost 8 years, 7, it is 8.0, 7 years we have completed. So India level in idea lab, our college is number 1. And IEC also we are top performer. So if you have any doubt in IoT, machine learning, or any material processing, material techniques, or you need some programming, if you want to collaboratively do journal works, publications also, I am ready to work. So now it is open for the question session. So you can ask the questions. Yes, sir. Hello, sir. Sir, am I audible?
Sir, you are audible, sir.
Yes, sir. If you want the participant, they can raise the question. Or if you have any doubt, you can ask.
Okay, sir.
Or even you can message itself, text itself, it is okay. Hello, participants.
Sir, yes, sir.
Yes, sir. You have any doubts, you can ask. Sir.
Yes, sir. I have posted in the message box, sir.
Okay, what is the effect of data imbalance? Limited failure data versus abundant elastic data on AI prediction reliability. So the data imbalance, that is actually in initial stage it is very limited, but now in today's machine learning versus deep learning, like plasticity versus elasticity, the material failure is increased because of the fabrication method in traditional methods are there. In powder methodology, we can reduce this elastic problem. AI prediction reliability is very high, sir, but the cost is high now. But the sensors rate also increasing. So the prediction reliability is in research only, sir.
Okay, sir. Sir, one more question, sir.
Yes,
Can AI predict?
Can AI predict?
Sir, can AI predict time-dependent mechanical behavior, sir, such as we will do it in polymer materials? For example, creep test we will take,
Yes, sir.
just relaxation test we will take. In that, whether AI can be used to predict the time-limited, time-dependent mechanical behavior, sir? Is there any
Yes, sir.
possibility?
Yes, sir. Yes, sir. That is the advantage of this AI. Initially, before AI, first of all, we need to in creep, which one you are putting the pressure or temperature, sir. You are going to be static. Two methods
Yeah,
are there.
pressure,
Once we
sir.
can fix the pressure and put in some time, or we can able to put the temperature. Two
Okay.
sensors we can able to put the machine. The testing kit is available.
Okay.
So the data every second we can able to track, sir, because we need to wait for 8 hours or 24 hours
Okay.
in creep. So
Okay.
every second we can able to calculate from the sensors, that is IoT. From the
Okay.
sensor, it will send the data only to the cloud. So
Okay.
from the cloud, we are taking the data, depends upon the new material, because the polymer material, if it is a primitive material, we can have the data. If it is a composite new material, the data, previous data is not available. We need the machine should learn. So take the data into the cloud. Every second we need to take the data and we need to put some tabulation, some graphs. So
Yes,
from
sir.
the graph, we need to put the threshold value. We need to teach the machine this is the problem happened to the material. After 5 or 10 testing learning, automatically the AI will give suggestion or instantly they will replay. So some studies are there in Annamalai University, they are doing Chidambaram. Some studies are there. So they are taking the data in real time, the data, sir.
Sir, facility name, sir, actually?
Actually, if you go and check in Annamalai University,
Okay.
that creep analysis, there is one student is doing PhD in that. They are set up the model is there.
Okay.
So it is like a wait a minute. I will tell the name also. Okay, that is like a the machine is nothing but he didn't name the machine.
Okay.
It is like they started the algorithm like stockfish. So
Starfish.
evaluate the positional and long-term plans. It is the algorithm name is stockfish. It is locally GitHub they are generated. So they are testing in the real-time machines.
On
Further, if you want,
in GitHub, he has got the data and he has tested with this algorithm. Correct,
yes,
sir?
yes, it is not yet published. It is in research only. If
Okay.
you want in collaboration, you
Okay.
can text me mail. So we will collaboratively do that research, sir. It is
Okay,
in
sir.
research.
Actually, we
If
have,
you want any algorithm required that, I will share in unofficially.
okay, sir. We have done this research work for polymers, sir, related to this stress analysis and creep mechanisms. Also, we have found out with the physical value of mechanical behavior through normal traditional testing process, sir. Just we
Okay.
need to do the same with the AI so that how far the AI predict the accuracy level that we want to check.
You are the right person connected to the FDP. Actually, this FDP, this presentation that is the main important. Whatever you are doing in traditional method, we need to convert into automation through AI. So
Yes,
we
sir.
have lot of algorithm for that. Later you can mail us or connect with me. So
Okay.
we can discuss in this abstract. So whatever the problem you have done traditionally, just to explain in one page, so that I
Okay.
will help you. What are all the algorithms you required or preferred to make this into automations. So we
Okay,
need to
sir.
do in machine learning, like TensorFlow is there. We can take some sampling. So then we
Sampling I
can
have
go
done,
for
sir.
sampling. Then we can able to finalize the which one is better model for you.
Okay, okay, sir. Okay,
Okay.
sir. Actually, I am working on that polymers only, sir. That's why I have asked.
So
I have done
my
2-3.
PhD is also a polymer only, glass fiber reinforcement polymer.
Okay.
So I have tested in the CNC machine data. Then I compared with the AI model only, machine learning. It will work.
Okay,
So
sir.
I have optimized using the response surface methodology and compared with the Taguchi method also.
Okay.
But latest machine learning is really advanced when compared to Taguchi and
RSM and
RSM. Because when I started my PhD 2014, RSM and Taguchi is in very high. But
high.
when I am completing PhD, automatically machine learning is evolved. Same data, I have worked in machine learning. Whatever I have done in 4 years, within 3 months I can get the data with 95% accuracy.
95% accuracy.
Yes,
Okay.
initially started from my manual method and Taguchi method. RSM, it takes 4 years for me. After the learning from the machine learning, within 3 months, actually the work is only 6 hours only.
6
But
hours.
3 months we need to learn to get the work that algorithm. So it will give
Okay.
98% accurate results. Sir.
Okay, sir. I will get your contact details from Dr. Muthukumar, sir. We
Yes,
can
sir. Yes,
discuss
sir.
further
He is
later.
the
We can look
100%.
for other audience also. The Uma Mageshwar Rao has
Yes.
posted the question, sir.
Yes.
Can we do machine learning algorithm optimization for L16? He is asking, sir.
Yes, sir.
Orthogonal array,
Same.
or do we need more data like 32, 64, 128 experiments to be conducted?
Yes, it is very easy if you are using Taguchi L16, 32, 64, 138. But in free version, you can't able to cross 64. But if you are a paid customer, you can able to up to e power x. E power x means like 16 power 16 also we can able to calculate. What you are saying 128, this is 2 power 8, 2 power 6. 2 power 16 also we can able to calculate using that machine learning basic algorithm.
Okay.
Yes, sir. Any other
Audience,
questions?
audience, is there any other questions from your side? Please post in the chat box so that professor will answer accordingly. I think there is no question. I will hand over the session to Dr. Muthukumar, sir.
Thank you, sir. Sir, I think you can stop sharing your screen, sir. There is multiple screens there. Yes, sir. Yes. Thank you, sir. So it is my duty to thank Dr. Martin over here, who has come in the middle of the Christmas Eve and has given us a wonderful session here. Actually, he has kindled the knowledge on the IoT, need for the requirement and integration of the multiple technologies. He has put multiple research questions into picture, and I think the audience will have much more questions about how we can do all these things in future, how we can implement in the research, how we can do as a research scholar, all these things. We'll correctly take forward these questions through all these communications, whatever they have as a questionnaire. If they are posting it, and I will post it to the speaker also. Sir, my personal question, sir, I have a personal question, like for setting up the Idea Lab, what initial steps we need to take from mechanical engineering point of view?
Sir, as of the Idea Lab, it is for the college, not the department. But 50-70% the work is from the mechanical department, 20% is from the electronics department, remaining 10% is from the remaining computer department. All three together required to form the Idea Lab. Actually, you are applied or you are going to apply? You are asking, you are started or not started?
Not yet started, sir.
Started means we need to apply. Normally, from March month, the call for will come from the AICT.
Okay.
From the March month, we need to fill the application form for the like your college institute data, AICT data, like how much area, how much building. Normal question they will ask, you need to fill. They are checking whether your college is in the NRF ranking, whether your college is having NAC, whether your college is having NBA, whether more than 5 department, whether your college is having 10 years from the starting. If any one of the point is meeting, you are eligible to apply this Idea Lab. Then we need to, they have given the mandatory document. For the mandatory document, we will go and check the market availability. From that availability, we need to find the quotation from the market in your region to set up the Idea Lab, how much fund required or how much fund you request from the AICT, how much fund you are going to produce, how much fund you can get from the industry or the alumni. This year, it is fixed to do 30 lakhs. 90 lakhs the overall fund, 30 lakhs from college, 30 lakhs from AICT, 30 lakhs from the industry. So next year, the terms will be changed. According to that, you need to prepare a form and you need to apply. That is the first stage. Then they will call for the presentation for 30 minutes. So your principal is the chief mentor, and you need two persons. One is coordinator, another one is co-coordinator. So one mechanical faculty is compulsory. Another faculty may be ECE or EEE or computer science, depends upon your college. Even though in your college mechanical department is not there, you should hire one mechanical person for applying this Idea Lab. Then after presentation, they will select and they will send the sanction letter, and the remaining things will be followed by letters. Initially, March month, they will call for you need to apply. The mandatory document is available in now itself. You can go and check the manual. For Idea Lab, what are the machines, tools you need to require? That is a mandatory equipment. More than the equipments, if you want, you can purchase. Existing ecosystem also you need to combine with the Idea Lab.
Okay.
Yes, sir.
Thank you, sir. We want to also set up a center of excellence for alternative fuel, particularly biodiesel or hydrogen fuels. Sir.
Yes, sir.
We will require some expertise people like you who have set up facilities in the region of Puducherry.
Yes,
A
sir.
lot of industry connections through you. If it is coming, we will be very, very thankful to you.
Sure, sir. Sure, sir.
We look forward for a personal visit of you to Avadi, sir. We are a large organization. We have a university, 2 engineering colleges. Whenever you come over here, please give us a notification. We will
Yes,
be
sir. Yes, sir.
happy to
Actually,
accommodate you.
in online, it is very difficult to share everything.
Yes.
So I know actually I attended also as participants also. So it is very difficult. If it is offline means 98% it should be fruitful. So online only 10 to 15% only conversion rate. So definitely if you are inviting, I will come and we can collaboratively do the work, sir. Win-win situation, sir.
You're always invited, sir. Just give us a notification when you are coming here. We will make proper arrangements to get into conversation with you in person. Our students, our faculty members, our research scholars, everyone will have a nice opportunity interacting with you.
Sure, sir. Sure, sir. Sure, sir.
Thank you, thank you. I think there is no question, sir. But Uma Maheshwar Rao has posted a question, sir. Is it answered?
Yes, sir. I answered, sir.
Okay.
It is possible. Yes.
Yes, sir. Sir has answered, sir.
Everything is answered.
Yes, sir.
So we have another session like with him in the near future, as I assure, and I get an assurance from him. We'll get more interaction through him. This is only a starting of interaction with Dr. L. Martin here. We'll see him again, and hope we'll have real hands-on sessions. As you assured,
Yes, sir.
it
Yes,
will
sir.
be
Yes,
like a
sir.
workshop.
Yes, sir. Yes, sir.
Like a workshop, and I will make sure it is IoT. We have set up an IoT lab in our college, sir. New IoT and mechatronics lab is there.
Yes, sir.
And give a shape for that one also.
Yes, sir.
So sooner the visit, we will be better benefited, sir.
Sure, sir. Sure, sir.
Thank you. Thank you very much, sir. Thank you, sir.
Thank you. Thank you for the opportunity, sir. Thank you. Thank you, sir.
Thank you, sir.
Sir, shall I leave the session, sir?
Yes,
Yes,
sir,
sir.
you are free to leave the session, sir. I will give instruction for the audience. Sir.
Thank you. Thank you. Sir.
Thank you, sir. Thank you very much, sir. Audience who are in the session, if you have any questions, you can post through the email ID given in the pamphlet. My name, Dr. Muthukumar at the rate of welltechmultitech.org. Dr. L. Martin is good enough to answer your queries through email also. I will be in a gateway position to answer those questions. And given that occasion today is a Christmas, we have preponed the every session, and we have almost tried to give freedom in the afternoon so that you can go back to your home and or in your even if you are in your home, you can enjoy the lunch in the Christmas Eve. Happily spend time together with your family, and I hope all of you are having a very good Christmas time together. And this is a very auspicious time, and we'll look forward for a very good session in the tomorrow morning, 10 a.m. Tomorrow morning we have a session with Dr. LG Loganathan, and another session in the afternoon we are having with Dr. Narayana Swami, who is from Kamraj College. All the session details will be shared in the WhatsApp communication. Whoever has got any lag or any personal comments in the session details or anything, you feel free to post in the WhatsApp group. If you have not received any feedback link there, likewise you can post any inconvenience you are feeling or any change of timing you wanted to make according to your convenience of the audience, the fellow participants. We will adjust towards that. Thank you. Thank you very much for your time joining all the way through this holiday mode. I congratulate everyone for a cheerful participation. Thank you. Thank you very much.
Thank you, sir. And feedback